What is dependency injection and how it is implemented in Spring, or you say Spring Boot? So this is the first question in the series about Spring Boot interview Q&A. This Spring interview questions coming also apart from another series, that is, if you have watched the one of the previous videos, I have created mock series, right? So multiple mock interview series I am creating, and in those series I am putting some of the questions there, right? And the questions that are there, they are keeping in mind for the Java backend developer, and Spring Boot is one of the important technology that Java backend developer must know. So these things are there. So we are covering core Java data structure, and this is here the database, this Spring framework is coming into picture. So this is the very first question into that series. So this video I am going to link here in this one here. So go ahead and check out this GitHub link that is already available in the description and comment section. You will get a lot more such questions that will help a lot in your interview preparation. Now coming to the questions, we have to understand here dependency injection first, then we will understand how it is implemented in Spring. So let's see first, what is dependency injection? Dependency injection, it is a design pattern which is used to implement inversion of control. So this is dependency injection. It is a design pattern which is there to implement a concept that is known as inversion of control in software application. We'll see inversion of control with example in a while. It allows classes dependency to be supplied by an external source rather than class itself. External source manages the creation and life cycle of these dependencies. So how this comes into picture, let's see in a very generic, very simple term. So let's say I have a class A, right, which has couple of features f1, f2, f3. It has implemented this one. There is a class B that depends on class A. Okay, so this B class uses features of f1 like a dot f1, a dot f2, a dot f3. It will have class B has object of A, and it will call these functions directly. So how B can have the instance of the class A? So B can create, B in itself can create, because B is using the functions of A, features of A, right? So B can directly create the object of A and start calling the functions A, right? And this B class is yet another class that will be used by someone else, C, let's say C, right? So when C is using B, C will create the object of B and will call the this will be also exposed by, let's say, the function m1 and function m2, right? It will call, let's say, b dot m1, right? So you see, the control of creating the object B is depending on A, all right, and B in itself is creating that object. So the client or customer of class B is tightly coupled with A. It is using B, and along with B it is coupled with A. There will be, in future, there is a chance there can be any other better provider of all the features that is in here, like f1, f2, f3. So as a customer, as a client, I should be able to move from here from A to X very easily. But the way that it has implemented right now, that B is creating the object this directly, this won't be possible for C to do this one easily, right? How this is possible? So we see this tight coupling of the creating object in here, right? That is the problem with this one. Okay, so how this can be avoided? So if somehow whatever this object we are creating, so this object that is being created by B, somehow C can create this one, okay, and it can pass that object to B while calling it, and then call the function this one. In this case, clients will have flexibility to call whether it will again use B only, right? Along B, it can have integration of A or X, that is the call of the customer that they want to use it, because this is the common generic feature that is being used by the clients, and it is the responsibility of this one to provide that flexibility to the clients. So you see the problem and how we can prevent it by like passing on the responsibility of the creating object to the clients itself. This is what we call the dependency injection and inversion of control concept. This is what it is saying. It allows classes dependency to be supplied by an external source rather than class itself. So class, this is the class, it has a dependency of this one. This will not pass that implementation, but it will allow the external source, that is client, to pass that dependency. Now we have got the theoretical understanding about dependency injection. Now let's see all of it with the help of Java program. So here I have come to my IntelliJ IDE. I'm going to create a class in here, design dot. Let's say I want to have a functionality around printers. Let's say printer A is there that I want to have. So I have package design. Inside this I have created this printer. So inside this I want to have this very simplistic thing, basically print method. So this is simply printing this printer A is printing the doc. So there is another class, that is client class, I can say, client printer, that is using this one basically. In here I want the instance of this one. So what I will do, and inside that I just call dot print and I will pass this. So this will also expect a doc basically, and I will just pass that doc further to the printer. So this is the two things, like printer A and this one is there. So I want one more in here, like actual print user, printer user. Okay, so where I want to have the main class basically, where I can use everything. Let's say client printer is there. So I will just do cp new client printer, right? And I will here actually this is the first class that is to be there. So I will pass the my doc here that needs to be printed. So simplistic, like hypothetical methods that are there. So the flow will go like this: is the actual print user, which is using this client printer to print, and this client printer is, you can say, the kind of orchestrator among different printers that are out there, the like HP, Epsilon, other printers are there. So it is providing that interface or facilitation, you can say, right? So this, if I run this program with this main method, now everything will work perfectly fine, not an issue. But there are certain problems with this one that we just understood theoretically. So this one, client printer and call the printer that we are doing in here. So this is the printer A, this is creating the instance of this one directly in here. First and foremost thing, if I have to do like call the printer of this one, if I have to write the unit test of this one, then it will be very difficult to mock this behavior. Basically this is going to be very difficult in that case. Second thing, very important, now today I'm using a printer A because this is the orchestrator basically. Now tomorrow there is a, let's say, a better printer comes into picture, like printer B in terms of cost and this actual user wants to move to that one, to the new printer. So how client printer is going to facilitate that? It's not the thing that it cannot do. Basically, let's say if there is let's say there is a printer B coming into the market. It is in the market, right? Printer B is printing the doc. Now this client printer has to facilitate that one, right? So what is the straightforward option that it will do? So it has to do a lot of code changes here. You see, it has to do this one, and even not in this one in here, it has to create one more method also, like this one. So in here it will call this printer B, and the same thing it has to be done by the print user also, like client printer is there. So cp.print call the printer B, and this is how. So the exact requirement was that printer user wanted to move from printer A to printer B. So what all places I needed to make the change? So client printer change was needed in here, right? So that is what I had to change this. This is the yet another problem, like a lot of complexity is there with this, with the help of like it in this type of relationship that we are maintaining in here, right? Because you see, this is depending, this client printer is printing dependent on this printer class. That's not an issue, it will depend on that one, but the way this relationship is there is problematic. Tomorrow there is a printer C, printer D is coming, so I have to keep adding the things in here to just facilitate that interface. There is a better way that we understood, dependency injection. Dependency injection says instead of you creating these classes, let the client, let the framework, let the container, whatever is using me, this client printer, let them have create these instances and pass that one, right? So how it can be done? So let's say I will make the changes in this one directly. So let's say let's have a contract around all the printers, right? So they're printing it, right? So just have this printer interface in here, and in that printer basically, so what we will do, so void print string docs, this is the contract, right? This is the contract, and this will just implement printer. That's it. Printer B also implement this one in client printer. This is how client printer's life will be easy. See, this is the interface, this is the one. So I will just create a constructor of this one, and I will inject this dependency in here, and this call the printer. So I will just remove this one. You will see that just from this single method I will be able to facilitate any of the printer that is needed. So this is how it is rather. So now come to this print user, right? What I have to do, client printer new printer A, right? So cp, if as an printer user I want to take the services from printer A, so I don't have to make the changes in the client printer. I will just do this one. Later in time, if I want to use printer V, what I will do, I will just change this implementation to printer B, and this I will just rename it, and cpb, this will be done this way. Okay, so this one in here I am using printer A, in here I am using printer B. There is no change needed in the client printer. This is what we are saying, that instead of directly depending on the implementation or creating the instances our own, let's depend on the interfaces, the contract, and let the actual user make the call which class, which implementation they want to use it, right? So now this is very generic, this client printer, right? So if I run this program now, so I will be able to use both the printers very easily from this print user, print A, printer B. This is doing the job, right? So this is very easy and very easy in terms of testing or anything that you can say, like it is modular, it is testable, and I want to switch to different providers as many times as I need whenever they're coming with least amount of change. Okay, so that's the beauty of this one design pattern that is there. So let's move to the PPT. So this leads to more modular, testable and maintainable code that we just saw. So what are the benefits out of this one? Decoupling, testability, maintainability, flexibility comes with these ones. So these are all benefits that are coming with this one, right? So we just saw that. What are the different types of this dependency injection? Constructor injection is the one thing, setter injection is the one thing, and field injection is constructor injection. It's something that we just saw in here, right? So we just created the constructor. So if constructor is not there, we can have getter and setter this one. So if this constructor is not an option, I can have another way like set printer. So whoever the print user is there, they can pass the actual printer that they need to pass it in here, right? So that is how this dependency will be injected. Another one was the field injection. Field injection is right, I do not want to have this setter method, I do not want to have this client printer, but this field method only. So in this case, there are some sort of annotations comes into picture in here. So using those annotations, these dependency can be added directly. But best practices comes also in picture. Field injection is not recommended because it makes difficult to do the unit testing of the code basically, and if I want to do anything around it, right? So this is not recommended. Constructor injection and setter injection are way to go, and they are very used widely. So I have also not used field injection very often. Nowhere I have used field injection. It is constructor or setter injection only. Constructor injection must be used when there is a mandatory dependency, like some dependency is there, without that my class cannot work basically. So for those dependencies, always go with the constructor injection. If there is any optional dependency that can be taken care later on, and so that those dependencies must be set via setter injection. Let's say my class is there which has 10 methods are there, 5 methods can work without particular dependency. So but certain dependency is there that is always needed. So whatever always needed, add that in the constructor. Whatever optional is there, add that in the setter injection. That's the story of this one. Now let's understand dependency injection is Spring. So dependency injection is the core of the Spring basically. Everything around Spring, like most of the places, everywhere you will see the dependency injection is Spring. So let's see this. These are the different options: constructor injection, setter injection, field injection. So now let's see each of these one by one with the help of program. You see, we have this Spring Boot application already created in one of the previous videos. So I am just reusing that one to explain dependency injection is Spring. So if I open this one main in here and I come to this repository class in here. So this is the basically repository class is there, and this service is there, unique ID service basically. Inside this unique ID service, you will see this unique ID service is depending on all these things, all these UID7, sequential, Snowflake and generated ID repositories. So how, but this is nowhere you will see that it is using the new operator. It is using this construct, this annotation in here, right? And this annotation is an example of, this annotation is an example of that field injection. We have another example, like if I want to go ahead with the constructor, so I can just use the constructor and I can pass these on in here, right? So if I'm using the constructor in this way, I can just remove these auto wire annotation. So one of that should be used, right? So I can comment this out, and this constructor will make sure that these are injected in here. And there is this auto wire optional to inject these dependencies in here. uh, this auto add annotation is an optional. Why this is an optional? This is the service annotation. The moment I use service annotation, the Spring container will try to create the constructor of unique ID service with the help of this constructor. When it is creating this constructor, it will look for these dependencies: UID v7 generator, sequential ID generator, and others. So let's take a look on this one. This UID v7 generator is also annotated with @service annotation. That means it will create that instance automatically. And if you see the dependency of this one, there is no external dependency of this UID v7 generator. So whatever default constructor is there, that will be created out of this one. Okay. The same is the story with all other generators that are there. UID v7. This is also @service. Snowflake ID. This is also @service. So this will be created by the Spring container in itself, and whenever we are creating the unique ID service, all of those will be automatically inject. And if one of that is not available, Spring, the server won't start basically when you try to start that application. So this is the way that constructor injection and this field injection. And the another way that we already understood, like I can have the setter around this one. Okay, and whoever is using this unique ID service, right, and these setters basically, I can use this auto add annotations in here, and this will make sure that whenever you are calling these ones, this dependency will be injected automatically, right? So that is it about the setter, constructor, and field injection that is there, and how they are used in the Spring itself. Now let's see how those instances are created. Basically we saw that, right? So configuring these beans in the Spring, there are different ways: annotations, Java config, and XML config. Let's see. One we already saw. This is the one of the way, that is @service, this instance gets created. But there is another way also. Let me show you that. I can create a config class. Okay, there is this annotation configuration. Okay, in this config annotation, I can have, let's say, I want to have a UID v7 generator, right? So this constructor, and this is how. So far we have not used new operator because we were using @service annotation, but we have now option. I can just, if I do not want to use this @service annotation, I can use the Java configuration with the help of annotation. So first one is the annotation configuration. This will tell the Spring container that this is the configuration, and you have to execute it before creating any constructor or doing anything else here. And here there is this annotation @bean. So when it will find that @bean annotation is there, so it will create it, and it will have that instance created, UID v7 generator. And then this instance is available with the Spring container. So wherever it is needed, it will be injected. So where it is needed in here, UID v7 generator, so it will be injected in here directly, right? The same way I can have other constructor as well, sequential ID, Snowflake ID, and all that. But we have convenient way of generating it using the service annotation, so we do not use this configuration unless it is needed. The last option that we had is the XML configuration. Basically XML configuration was initially used in the Spring, but nowadays I have not seen it used anywhere. But basically there is a XML file that gets generated. So let me show you that how that basically looks like. Spring dot XML, and this is how the content of this one looks like this beans annotation is there, bean id dependency b is there, service a is there, service a, and this constructor r graph. So this is the complex, like this was the, still even today it works very well, not an issue, but we have more convenient way of creating the instances like java configuration and these annotation. So it is kind of, you can say, old school xml. So there is no where it is being, but for the legacy applications, if they are there in the companies, so they are used in here. But with spring boot coming into picture and all that, it's rarely used nowadays. So that is it about dependency injection in the spring and how it is implemented in here. I hope you got the complete understanding. If still there is any confusion, put that in comment section. I'll be happy to help you out. And please don't forget to subscribe the channel, share it with your friends, and like the video. I'll see you in the next one. Till then, take care. Bye bye.